But what was really lovely is there was a lot of focus on why we need the social and the socio part of socio-technical. So there was a big focus on that. So we fitted in quite well as Athena. So I'll now share my presentation and I'll give the talk as I did, and welcome any questions, although some of this you guys will already have seen before. So, right. There we go. Okay, so this is on the presentation of our paper, which was written with Torvald and Ben on tailored extended reality environments for education and training in cybersecurity engagement beyond awareness. So in this presentation, I talk a little bit about cybersecurity training for operational technology before moving on to extended reality or XR environments and their benefits, and how they have the potential to be designed as social spaces, and how, in the end, this process of co-creating extended reality environments that act as social spaces for OT personnel have potential to create environments for cybersecurity training that goes from awareness training to engaging people with cybersecurity and building skills and skill acquisition rather than just knowledge acquisition. And I'll finish up with some of the ethical considerations and the conclusion. So before I start, just to introduce the topic, this research is in connection with a larger project, the Athena project, which is looking at creating innovative trainings, including trainings based in mixed or extended reality for OT personnel in cybersecurity and critical water infrastructures. So in recent years, we've seen an increase of connectivity between IT and OT systems, which has brought new opportunities, particularly with automation of systems and critical infrastructures. But it also opens up these systems to new vulnerabilities because OT systems traditionally have been built to last. So they're legacy systems, which means they're now more vulnerable to cybersecurity attacks. And awareness-based trainings, which is the current most popular form of training for non-IT personnel, is great for things like knowledge acquisition, but there is less focus on building up people's skills and competencies and things like soft skills of communication. So how do you communicate if you spot something that's suspicious across a hierarchical chain? And also things like metacognitive skills for people to build up their metacognition so that they can think through if they're faced with something suspicious. And previously, where there's been an attitude in cybersecurity of humans as maybe the problem or something that needs to be controlled, in this project, we're trying to see OT personnel as the first line of defense in an organizational chain. So if we can train people to get them to engage with cybersecurity, there is a chance that they will detect, recognize, and respond appropriately to cyber threats and escalate this to the appropriate people within that organizational chain. So with current approaches to an operational technology, from previous research with a scoping review and some recent interviews with OT personnel, we found that a lot of the training for OT focuses on IT-based risks, and there's primarily a focus on awareness and avoidance of that risk. When we found there were specialized trainings for OT systems, which focused on things like test beds or digital twins, this was focused on training cybersecurity experts who could then handle those risks for operators rather than used for operators themselves. And the other thing that we found is that one of the things that was a knowledge gap in the research was that there are key factors of organization, social, and communication skills, which actually, if improved, could boost the resilience of organizations in cybersecurity. And this is where XR environments and extended reality comes in. So we have different types of XR environments. You have augmented reality, where you have a object like a mobile phone and people can see virtual elements within their real world environment. You have mixed reality, where people are placed in an environment that has both real world and virtual elements. And you have virtual reality, which gives you a full, isolated, immersive experience. And one of the real benefits with XR systems is that you can have close to reality, cost-effective simulations of operational technologies. Operational OT systems are not often able to be taken offline for training, and recreating physical simulations, so taking a desk and rebuilding it for training purposes, can be very expensive. So XR environments have the potential to be actually a more cost-effective solution for these critical infrastructures. One of the pieces of feedback that we've had from recent interviews was that people were interested in particularly VR because it would give them the chance to make mistakes in these systems. So, for example, if you make a mistake on a real system, that can have quite serious consequences for the critical infrastructure as a whole, whereas in VR, that's not connected to any kind of services that are essential for society. There's also the option in VR and XR environments to visualize complex data, which, particularly for non-IT personnel, can actually help them to feel more oriented in a situation, and it aids their learning because they can see the complex data that they're interacting with, and it lowers the cognitive load, particularly during teamwork exercises. So the conclusion of the benefits is that these really have potential to be tailored, high-fidelity simulations of OT systems. But there is also the potential to take this further and to consider how critical infrastructures themselves are not just isolated objects. One of the things that came out of interviews was that people embed these critical infrastructures within their national and social context. So there are different motivations that people come into these critical infrastructures because they want to work with something that is directly related to their social context. And as we know from previous research on cybersecurity, one of the really useful models for looking at cybersecurity in these sorts of systems is looking at them as hybrid spaces. So, for example, if someone encounters suspicious activity, they have to operate across two different axes. So there's the physical and the cyber systems, and there's the strategic and tactical level. And one of the key things is getting people to be able to orient themselves in that space under stressful conditions so that they can orient themselves, locate where they are in that hybrid space, and be able to then handle a situation and respond appropriately. And with designing a tailored virtual reality or extended reality environment, you have the chance to take that national social context and embed elements and knowledge and ideas from that context into an XR environment. So, a lot of early discussions on virtual reality environments focused on the idea that you need to understand the cognitive links that people make between their social context and the virtual environment that they go into. And often people will base their behaviors in a new place on common cultural elements or a spatial attachment to a behavior that they have from a different social space. It's a bit like when we go into a library and you know how to act in a library because you've been in a library previously and you have that idea of, okay, a library is a quiet space for reading. So you emulate those behaviors. And one of the things that we can do with virtual environments and extended reality environments is you can tailor that to an organizational culture. So you can take the knowledge, the ideas, and the social practices from that organizational culture and put that into a virtual reality environment. And then you have a very tailored experience for people from that organization. So you end up with a highly specific training where someone's able to orient themselves because they understand the context around them. And it makes it easier then to acquire the new knowledge because they already have some familiarity with that system. One thing that's really important in this is therefore co-creation. There has been a lot of research in cybersecurity on the idea that if there is a training that is not fit for the end user or the end user is not involved, this can result in poorer engagement and a poorer retention of the desired behaviors and knowledge. Whereas if you co-create the training and involve the end user, you can give the end user a sense of ownership, which has the potential afterwards to have a better engagement from those end users, and then you get a higher uptake and retention of knowledge and skills. And this is what the Athena project is working towards. And part of the Athena project is co-creating these extended reality environments for OT personnel. We've had some pilot testing of this with an XR cybersecurity experience in critical water infrastructure, and this was a pilot of the environment itself. And from the OT personnel that took this, the feedback was very positive, particularly that it made cybersecurity feel real and that they wanted more realistic and more specific tailoring to their environments. But what was really interesting was that after, in a post-pilot discussion, there were examples of people linking cybersecurity and the sorts of things they'd seen in the pilot experience to current events. So this training took place, or rather experience took place, just after recent telecommunication attacks in Lebanon. And people who went through this environment were linking it to that, but also to social and cultural knowledge and the idea that they were motivated to protect the infrastructure that they worked for, but also the society that they were in. And this feedback is in turn influencing the design of new scenarios. And where we go from moving from awareness to engagement is that there is a real potential with extended reality environments to foster domain-specific self-efficacy and metacognitive skills. And this is about building up people's resilience. And self-efficacy is the perception an individual has that they can persevere with and achieve a difficult task under stressful situations because they have the skills and they believe that they have the skills to handle that task. However, there isn't much research yet. It's a growing field on interventions that specifically focus on building self-efficacy. And the question that we now have is, can extended reality environments facilitate building self-efficacy in cybersecurity? Well, the results from this are forthcoming in a further study that we're undertaking currently, but the initial results are encouraging rather, and there is a potential to build self-efficacy that is transferable from that extended reality environment into a real-world scenario, especially if we can build cognitive and spatial links and senses of attachment to behavior from that XR environment into a real-world scenario. This is not without ethical concerns, and one of the risks with a high-fidelity simulation is if it is too organizationally specific, you may end up with a digital twin that is a potential attack blueprint for another threat actor if it fell into the wrong hands. So there is a need for securing these environments. And metacognition is not a magic bullet. People can be aware of risky behavior, and we've seen this before where people have been aware or thought something was a scam, but because they were anxious or they were under stress, they still partake in and fall victim to that scam, even though they're aware that this is probably something that is a risk. And finally, there is a risk with building any kind of virtual or physical social space that you can include pre-existing biases or discriminatory practices within those spaces. And one of the things that affects cybersecurity is there is some research that certain demographics may or may not be more susceptible to be insider threats. And there is a question now of how can we use this information without profiling and discriminating against particular groups. So to conclude the presentation, what we're looking into is the potential of extended reality environments for providing high fidelity, cost-effective, tailored training for OT personnel and critical infrastructures. And within the Athena project, we're currently testing out these extended reality environments and their relationship to self-efficacy. It's important to mention and to understand going forward with future work that this is not a magic bullet, but as part of a holistic approach to cybersecurity, it can be a useful tool using things like extended reality environments. So I'd like to acknowledge the Athena project for their support with this presentation, and I open the floor to questions. Thank you very much.